Imagine this for a second. You're living in a world where the sky above you is completely figured out. It's written in stone, unquestioned for literally 2 millennia. You're taught that the Earth is this heavy, unmoving rock sitting right at the center of everything, and the heavens up above, well, they're a realm of absolute, unblemished perfection. Welcome to today's explainer. We're jumping right into the epic, world-shifting story of a man who decided to point a simple glass tube at the sky and, just like that, completely rewrote our understanding of the universe. We're talking about the life, the sheer genius, and the intense trials of Galileo Galilei, the father of modern science. So, the big question we're tackling today is this. What actually happens when one man's eyes challenge centuries of locked-in belief? You have to understand, up until the early 17th century, humanity was basically stuck in a 2,000-year-old illusion created by Aristotle. The absolute reigning dogma, which was backed by all the top academics and the church, was the Ptolemaic system. This system basically said, hey, Earth is perfectly motionless at the center of the cosmos, and the sun, the moon, all the stars, they all revolve around us, right? It was a very comfortable, very human-centric view of reality. But the truth? Well, the truth has a funny way of showing itself to anyone who actually stops and decides to take a look. Section 1. Shattering the Ancient Sky, the Dawn of Telescopic Astronomy. Okay, let's set the scene. It's 1609. Galileo takes a brand new Dutch invention, this thing called a spyglass, and he drastically improves it, creating a telescope that magnifies things 30 times. Now, instead of looking at ships on the ocean, he points it straight up. Look at this quote from his 1610 pamphlet, The Starry Messenger. Before this exact moment, everyone believed celestial bodies were these perfect, completely smooth spheres made of some magical fifth element. But through his lens, Galileo sees dark shadows, he sees towering mountains, he sees deep craters. With just one glance, he totally shatters that ancient idea of heavenly perfection. He proves the moon is actually rough, uneven, and made of imperfect stuff. Honestly, just like the Earth. And that first look, it kicked off an absolute avalanche of discoveries. In early 1610, he's mapping out the moon's surface. By January, he points his telescope over to Jupiter and notices something super weird. 4 distinct little stars next to the planet that keep changing positions night after night. It hits him. These aren't stars at all. They're moons orbiting Jupiter. We know them today as Io, Europa, Ganymede, and Callisto. Then, later that year, he's looking at Venus and realizes it goes through phases, exactly like our moon does. Guys, this was the smoking gun. Venus could only go through phases like that if it was orbiting the sun, not the Earth. This sets up a massive paradigm shift. It's the old world versus the new world. You've got the old Aristotelian heavens, Earth-centered, perfect, totally unchanging. And then you have the new Galilean universe. Finding Jupiter's moons proved that, hey, not everything revolves around the Earth. He even observed sunspots, literal dark blemishes on the sun, proving the heavens were imperfect and constantly changing. Every single thing he saw provided hard physical evidence for heliocentrism. That's the theory Nicolaus Copernicus had proposed, saying the Earth and planets revolve around a relatively stationary sun. Section 2. Rewriting the laws of motion. Heavens to the Earth. But Galileo didn't just keep his head in the clouds. He brought that exact same demand for hard evidence right back down to Earth. He wanted a unified mathematical way to understand matter. So he goes after another one of Aristotle's unquestioned rules. For nearly 2,000 years, everyone just blindly accepted that heavier objects fall faster than lighter ones. I mean, it kind of makes intuitive sense, right? You'd think a boulder drops faster than a tiny pebble. But Galileo didn't care about intuition. He cared about proof. Through these incredibly careful, controlled experiments, he showed that all objects, no matter how much they weigh, fall with the exact same constant acceleration, as long as gravity is the only thing acting on them. Now, you might be wondering, how in the world did he prove that when things fall so blindingly fast? 16th century tech obviously couldn't measure vertical freefall speed. This is where his absolute genius comes in. He built these smoothly polished inclined planes, ramps, basically. By rolling balls down these ramps, he effectively slowed down gravity. This let him actually measure the time and distance using these primitive water clocks. And boom, he discovers that the distance an object falls is proportional to the square of the time that passes. He even used these same math principles to track the curved parabolic paths of projectiles. It was a massive breakthrough for physics. He was also fascinated by pendulums. The famous legend is that he was watching a chandelier swinging back and forth in a cathedral in Pisa, and he realizes something amazing. The time it takes for a pendulum to make one full swing back and forth, its period, depends solely on the length of the string.
It doesn't matter how wide the swing is or how heavy the weight at the bottom is. It's called the isochronism of the pendulum. By figuring this out, Galileo essentially introduced time as a precise, measurable parameter in physics, which completely paved the way for accurate clocks.
And he didn't stop there. In the old Aristotelian physics, people thought that if you stop pushing an object, it naturally stops moving, like you need a continuous force just to keep something going. Galileo completely dismantled that idea. He formulated an early version of inertia. He reasoned that if an object is moving on a perfectly smooth, completely frictionless surface, it's just going to keep moving forever. Objects stay in motion unless something else stops them. By throwing out the old rules, he literally planted the seeds for what Isaac Newton would eventually turn into his first law of motion. Section 3. Inquisition and Trial, Truth and Authority.
But as you can imagine, rewriting the heavens and tossing out the laws of physics came with a really terrible cost. It set off a massive collision between empirical truth and strict institutional authority. Like we touched on earlier, heliocentrism is the model that puts the sun right at the center of the solar system. Galileo's telescope was making this impossible to ignore, and this caused incredible friction with the Catholic Church, because their theological views were super tied to the Earth-centered model. Back in 1616, the Inquisition actually warned Galileo, do not hold or defend heliocentrism. But skip ahead to 1632, Galileo is feeling bold, and he publishes his absolute masterpiece, the Dialogue Concerning the Two Chief World Systems. It was written like a debate, sure, but it clearly and masterfully destroyed the Earth-centered view and totally championed the sun-centered system.
The backlash to that book was swift, and it was devastating. Galileo lost his political cover and was dragged to Rome to face the Inquisition. In 1633, the sentence dropped, and it was crushing. He was found vehemently suspect of heresy, all just for saying the sun sits still at the center of the world. Facing the threat of actual torture, this brilliant, aging astronomer was forced down on his knees to publicly abjure, curse, and detest his own scientific discoveries. He was sentenced to prison, which they quickly changed to house arrest for the rest of his life. On top of that, his great dialogue was completely banned, along with anything else he might ever write. But here's the thing. You just cannot lock away a mind like Galileo's. This is honestly what's so inspiring about the guy. His story isn't just a tragedy. It's this incredible triumph of human resilience. He's confined to his house in Archetri, his eyesight is failing him, but he doesn't stop working. He spends his last years formally writing down his entire life's work on mechanics and motion. He actually managed to smuggle the manuscript out to the Netherlands, where it was published in 1638 under the title Two New Sciences. Written entirely in the shadows of his house arrest, that book basically became the bedrock of modern physics. Section 4. Legacy of Modern Science, Enduring Impact. Galileo died in 1642, still a prisoner in his own home. But while the man himself passed away, his ideas had completely escaped. They spread like wildfire across Europe, entirely unstoppable, changing how humanity interacts with the physical world forever. See, Galileo didn't just make discoveries. He completely changed the way we discover. By demanding hard numbers, controlled experiments, and mathematical proof, he pioneered the modern scientific method. His work on falling bodies and inertia, it was picked up directly by Isaac Newton, who, crazy enough, was born the very year Galileo died. Newton took those ideas and built his laws of motion and gravitation, and Galileo's legacy literally reaches the stars. Fast forward to 1989, NASA launches the Galileo spacecraft. It flew a 14-year mission to orbit Jupiter and study those exact same moons Galileo spotted with his homemade tube of glass 400 years prior. Moons like Europa, which we now know has a massive subsurface ocean, making it one of our best bets for finding extraterrestrial life. So, as we wrap up this explainer, I want to leave you with one final thought to chew on. Galileo looked up and proved that the universe was so much more complex and dynamic than anyone had ever dreamed. If one man, armed with a homemade spyglass and the sheer courage to just look for himself, could completely shatter a 2,000-year-old cosmic illusion, what accepted truths in our world right now are just sitting there, waiting for someone to build a new lens? What dogmas are we all holding on to today, simply because we haven't dared to look at them differently yet? Keep questioning, keep observing, and thanks so much for joining me on this explainer.